Greetings, guys, and don't worry, we're going to start the meeting in a moment. Today, as I put inside the voice chat, inside our chat box, we're going to do another AI programming. Today's program is going to be about the vacuum cleaner, which is a simple reflex agent. So we're going to teach you guys how to program that from the ground up, just same as the classifier for coding one. So in a moment, our lecturer are going to share a screen and give you a revision on what the simple reflex agent was. And then our tutors will get the carry on the meeting with the code. And at the end, if there is some, I'm going to do a recap of the entirety of the session myself as well. So I hope you enjoy it. Sorry if it's taking a bit. Don't worry, we're going to start very short. Thank you.
Okay, hello guys. So before starting today's session, let's do a very quick recap of the simple reflex agent. So as we have learned before, simple reflex agent is the simplest of all of the types of the agents. So it only operates based on the condition action rule, right? So uh, it operates if the current state is something, then I will do this, or if not, then I will do another thing. So as we have learned before, simple reflex agent does not consider any memory input, and it doesn't consider any like historical data. So in other words, it doesn't care what happened in the past or what will happen in the future as a result of my action. So it will only consider what will be my present action, right? So here are the characteristics of the simple reflex agent. Uh, as it's very simple, it has very limited intelligence, right? And the actions of the simple reflex agent does not depend on percept history. It only depends on current percept. So in today's example, we're going to look at the vacuum cleaning bot. So uh, vacuum cleaner bot. So in simple words, being a simple agent, it only considers what it has in front of you, right? So so as it doesn't store any information about the past, it has no memory requirements, and yeah. So in case of a vacuum cleaner, we talked about one possible problem, which is an infinite loop. So in order to get out of this infinite loop, either we have to know the environment fully, or we need to randomize the action of our simple reflex agent to uh, avoid the situation of infinite loop. Okay, so let's again look at this example once more. So uh, agent function of a vacuum cleaning agent looks something like, if the current status is dirty, then it will clean the floor. Otherwise, it will move to the next location. It will can move right or left, right? Yeah. So these are all the characteristics basically. So let's move on to the next tutorial sessions. Thank you.
Hello, hello. Can you hear me?
Yes, we can hear you.
Okay. So this is the code. Okay. So this program, well, imagine like a room where there are tiles, like square tiles, and those tiles can either be clean or dirty. So this program simulates generating a floor of square tiles and then a vacuum to clean those tiles if they are dirty. So we'll start with the most basic unit of this scenario would be obviously the square. So the square object, firstly, I don't expect you to understand all of the code, but I hope you understand like the how each function works and how they all play together as a part. So the first basic unit in this scenario is the square, the square object. So this square object has two instance variables, boolean dirty and square north, south, east, and west. Well, five lah, if you count each one. So the boolean dirty variable is to determine if the square is dirty or not. So if it's dirty, it will be true. If not, it will be false. And then these four squares are to indicate the north, south, east, and the west squares of this particular square. So the constructor is a public square, one where the parameter has dirty and with all of the other squares. So this method dirty will return dirty if it is, will return true if it's dirty or false if it is not dirty. This method change state is going to change the state. For example, if the tile is dirty, then it will change it to false. So it will clean the tile. Else, it will stay dirty. And then these are the getters and setters, the accessors and mutators. The get north, set north, get south, set south. This is to set your instance variables up here. And finally, we have toString. What toString basically does is it'll print the tiles. If it is dirty, then it will return D. Else, if it's clean, it will return C. And then here is the vacuum object. So the vacuum object has three instance variables, a square object of location, because we need to know where it starts and where it currently is. And then there's integer moves to count the number of moves it's done. And then the integer total suck to count how many sucks it has done for that particular runtime. So we have the method move. Here the initial state of has moved is false, meaning that it has not moved. And then while it has not moved, then you try to move. So what this statement basically does is it uh, it generates number from 0 to 3. So it'll do one of these and then see if can move north. So if you can move north, let's try to see can move north. You if this can move north method returns a boolean. So uh, return location dot get north is not equals to null. So while get north is not empty, not equals to null. Get north is not empty. So if we can move north, then we set location north. Else, if we can't do that, if we can move south, then we'll set the location to south, and likewise. And then we have the method suck, which says that if the location is dirty, so this dirty method will return the dirty boolean. So if it is dirty, it will return true, false. So if it is dirty, then location dot change state. So this invokes the method from the square class, the change state method, this one. So if it is dirty, then it'll change the dirty boolean to false. So then it'll be clean. And then you increment the total sucks, so you can keep track of the total sucks. This is the set location. To set the location, the instance variable location. This is get moves, which returns the total moves for the vacuum, how many moves it's done. This returns the total number of sucks it's done, and these are the methods to check if they can move in the direction stated. Okay, so that is done for the first half. The second half, environment and main, will be done by my friend Famin. Okay, so thank you.
Hi, Assalamualaikum. Hello everyone. Let me try to share my screen. Okay, can everyone see my screen? Okay. So basically, continue from Ain explanation just now. So before that, how do I zoom? Okay. Control Shift. Can everyone see the code here, or is it too small? Oh, okay. 10 minutes good. Okay. All right. So continue from scroll the mouse by holding alternate. Okay. Oh, okay. Okay. So continue from Ain explanation just now. So first, just now we initialize the square. Basically, what we have is imagine we have a square for each of this one, and then we initialize the vacuum itself, and then the next thing that we need to do is to set up an environment. So basically what we do is we ask for input from user for how many the type of environment that we want. For example, we want to create a 3 by 10 environment here. So we can have, first we need to initialize the environment lah. Okay, so what we have here is the environment class here. So this environment class is taking the square that we just initialized in the square method just now, and then have a vacuum variable here which will indicate where the location of vacuum in this square. Okay, so this environment class has two type of constructor. The first one is the vacuum, which is the one that Ain explained just now, and then we have the square, the specific square in this environment. Okay, so when we get an input from user, first what we need to do is, within our code, what we need to do is to initialize the vacuum, which is we are calling this class here. So this vacuum equal to vacuum is basically we are calling this class here, okay, to initialize the square location. Sorry, here to initialize that all of these, we initialize all of this square to be um, dirty first, and then its location to each north, south, and west as a null first. Okay, so basically for each of the square here, first we have the condition of that square, whether it's clean or dirty as a D, or null without any value. And then the next thing that we need to do is we need to set their neighbors. So basically for this square, who are the neighbors of this square? So basically we can set that this square here is the neighbor of this square. So we set for each of the square we have a x and y coordinate. So basically x here, this one is 0, 1, 2, 3, and then this one is 0 until 10 here. So for example, we have a coordinate here, 0, 0. We can set on the north side which square is on the north side of this square. Okay, all right. So by from the input that we set from user, we initialize the square that we have, the environment here. I mean, how many x and y that we have, and then after that we call this method that is to create floor and randomly set state. So this method is basically okay, this method is defined here. So within this method we have a initialize floor method. Okay, for initialize floor method, what we do is just now we just define that. Okay, for example, we want to create an environment of 4 by 10. So when we initialize that, we initialize it as a null square. So what we need to do next is to set the condition of the square. So here, when we call the method initialize floor, basically we are calling the square, the floor, the square class here, new square, and then we input the x and y from the user input. This one, it's basically from here. What is it? Okay. Okay, we basically create a new square here, 4 by 10, and then the next thing that we do is to okay, sorry, we actually initialize the floor first, basically 4 by 10 here, and then after that we generate the value inside of this specific square. Okay, so the next method is generate square here. So for generate square, this method is basically, okay, just now we have, for example, 4 by how many is this? 1, 2, 3, 7 here, for example. So we initialize this square to create an environment. So what we do next is we set the condition for each of the square. So by looping, because right now we have a x value and then y value. So what we do here is basically loop for each of the square that we have in here, and then set the condition of the square to be not dirty, for example. Okay, so let's say clean. Okay, so all of this square right now becomes clean. That's what this method does lah, basically generate square. And then the next thing that we do is to link square and randomly set dirty. So this method is basically defined here. So basically what we do here is the same thing. We look for each of the square that we have here, and then we set their north and east and then west neighbors location, for example. Okay, so basically let's say we have here for I equal to 0, which is I means I represent the x coordinate here, and then within that we look again for j equal to 0 here, which is the y coordinate here. So right now if I equal to 0 and then j equal to 0, which represent this square, we set link east west square method here, which what this method does is basically we set that, okay, if there are no value here, we don't have to set the neighbors for this square. Okay, this condition here. Okay, if there are neighbors for this square to the east, we set this square as a neighbor of this square. Okay, so this square here is basically 0, 0 by coordinate, and this square here is 0, 1, for example. So we set into this square variable that this square here is its neighbor to the east. Okay, so the same thing we do for east and west, and then north and south. Okay, so link north and south square here, basically the same thing. We check for each of the square here, we store the value inside this specific square, who are their neighbors to the north, to the south, west, and east. Okay. Okay, so if here is a condition to put so that it doesn't go out of this environment that we just set. Okay, let's say here, if j is less than 0 and if y is greater than 1, so basically this one is to link north and south. So let's say if j greater than 0 means all of the square that are north of 0 here. So if this condition is true, we can set the neighbors for this one. Okay. All right. So the next method is to randomly change states here. Okay. So this randomly change state of the square is basically for our demo purpose, we want to randomize the square here to be to make it as some of it can be dirty, some of it can be clean. Because when we initialize this all of this square before, we set it to be all of it to be clean. So for the purpose of our program here, we want to randomize the condition of this square here. Okay, we can set this one randomly as a, for example, dirty. Okay, this square can be dirty, and then this can be dirty. Okay, so how we do this is basically by calling this randomly change state method. So for example here, um, okay, so we are looping here. For means looping through each of the square that we have here. So by going through each of the square that we have here, we're calling randomly change state method here, and then this we'll call the randomly change state method, which is just a method here. So this method will randomize a value. For example, for this square, we can set it to be clean. We can randomly set to be clean or dirty, and then because the initial value of this square that we just set just now is all clean, so we then call this method change state to convert the value of the square just now into either dirty or clean by using this randomizer here. Okay. Right. So randomly change state. Okay, and then change the state of that after it we initialize to clean, and then okay, all right, so that's it for randomly change state method. So after after this one is finished, this method is executed. um, so we complete the method above it, which is this one, and then uh, okay, and then this one which belongs to this methods here is completed. Okay, so right now we have executed all of the method within this method. Okay, just now after we initialize the environment, we execute this method which has a different method inside of it, and then we complete that one. Okay, and then the next method that we run is basically run method lah. So this one, the run method is a method that we define here. Okay, So this run method basically contains four another methods within it. Okay, and then the first one is to generate vacuum location. Okay, so just now what we did just now is basically first initialize the environment, I mean the floor, uh, and then we first set all of the square within the floor to clean, and then we set the neighbors for each of the square, whether from the north, the east or the west. And then because we initialize it as all of it to be clean, we need to randomly select which square to be dirty or clean. Okay, that's what we did just now lah for create floor and randomly set state method. Okay, what we need to do next is basically after we have this condition here, um, what we need to do next is generate vacuum location. So because imagine we have this random environment, we also want to we need to set a place where vacuum can start to suck all of this dirt here. Okay, so this method generate vacuum location is basically what it does is first we randomly set the vacuum location. So it can be here, it can be here, it can be anywhere within this floor here. So this method, okay, as you can see, as long, okay, what we do here is basically while the floor is not null, so that means that we are within the floor that we just set just now, we just set here. What we have to do is randomly select a location within this floor. Okay, and then after that we can set the initial location of the vacuum. For example, it can be here. Okay, you can color this as red, for example. Okay, this is what this generate vacuum location do. Okay, and then what happen next is basically we need to display the initial floor that we just generate with the vacuum location. Okay, so what this do, okay, display initial floor do is basically it's calling another method here, which is display floor. Okay, here, so the same thing, just now we just set a condition inside of this square here, whether it can be dirty or clean. So what we need to do next is to display to the user that condition. Just now we just store the value inside a variable, we don't display it yet. So what we do next is to display the condition of that floor. So how we do it is basically we look. So basically we go through each of the square here by here and then go through all of it, and then we display the condition of that floor. Okay, that square, sorry. Okay, so looping here, go through each of the square and then print floor piece here. So this print floor piece is another method here. So what it says is basically if we did not set any value, let's say the square is outside of this floor, outside of let's say this square here, outside of the floor that we just defined, we display null. So basically because it is outside of our environment, so we have to display it as a null lah. Okay, and then if it is within our floor that we just defined, and then what we do here is basically display the value that we just set inside of that square. So this one system .out.print, and then we print this floor, because in the square that we just defined just now we have this value. Okay. Okay, this value here. All right. So we display that into the output that we will have later here lah. Okay, output here. Okay, and then after we print the initial floor that we just said, the next thing that we have to do is initial floor. So, and then we call this method to display the condition of each of the square. Okay, focus, and then okay. So we display the initial condition of this the square. So the next thing that we need to do is after we display the initial environment and the condition of each of the square that we just set, the next thing that we have to do is basically perform the action of cleaning the floor. So to recap, just now we initialize the environment here with a random value of dirty and clean for each of the square, and then we randomize the location of the vacuum. Okay, it can be anywhere here. So let's say for example it's here, and then the next thing that we have to do is to ask this vacuum to clean the square that is dirty. Okay, so how we do that? Okay, by using this clean the floor method here. So clean the floor method here, what it does is basically, okay, clean the floor. Okay, first it will check if the floor is clean. So it's calling this method check if floor is clean. So what this method does is basically, okay, it will again look through all of this square here, and then if you remember from Ain explanation just now, for each of this square we have a we have a getter methods here to get the condition of the square, whether it's clean or dirty. Okay, this one. Okay, so what this method does is basically go through each of the square that we have here and then check if it is clean or dirty, and then if it is dirty, for example here our initial location here is dirty, we just basically change the condition of the square here to clean. Okay, and then what we have to do next, okay, check if the floor is clean first. We check if we get dirty, we perform the method here, which is clean and move vacuum. So first we check if the randomly placed vacuum location is clean or dirty, and if it is dirty, for example the value that we have just now, dirty, what we have to do is perform this action, clean and move vacuum. So this method here, okay, it's perform another method inside of it, which is an action that is done within the vacuum method, which is sucks and then move. So if we go to vacuum class here, we can see, where is it? Sucks. Okay, sucks. So the suck method is basically what it says is basically just now we detect the whether it's dirty or clean. So what we do next is basically if it is dirty, if this method here is dirty, is from here, so it will return the boolean whether true or false. If it is dirty, for example true here, if it is true, location dot change state. So it will call this method here, change state. Change state in here. Okay, so if the square that we have here is dirty, it will return fast. Okay, if it is dirty, it will convert this condition of the square here into clean. Okay, and then what the next thing that it does is to store a value inside this variable here. That is this is what we call an incremental. So basically we initialize this total sucks value here first as 0. So whenever the vacuum detects that there are a dirty square, and then the vacuum perform the sucking action, so it will increment this value, this variable here of total sucks by 1. So this is basically what it does lah, total suck plus plus. So basically it will increment the number of sucks by 1. Okay, alright. So after the vacuum has performed the sucking method, the next method that this clean and move method does is basically to move. So after we just settle with this one, what we have to do is to move to a different location and then detect whether it's clean or not. Okay, so this move method here is from where is it? Where is move? Okay, move. This move method here. Okay, so basically the move method here, what it do, okay, just now when we initialize the environment just now, we said that for this square, who are the neighbor is. So if this square is sitting by the edge of this floor, we know that it doesn't have a square to the left and then to the south. Okay, so what this move method does is basically first it will randomize where to go, and then it will check if there are square to the north, to the south or to the west or to the right and to the top here. Okay, if there are square to the top and then to the right, it will set a new location. So basically it will ask this vacuum to move to the new location. Okay, for example here we can change this color. Okay, we set a new location. For example, just now the location of the vacuum is here, and then we check whether this vacuum can move to the left or to the top or to the right or not. If it can move to the right or top or bottom, we can then randomly choose that location, right? By using this method here. Okay, so let's say for example we detect that for this square we cannot move to the left, but we can move to the right, and then we set a new location for the vacuum here. Okay, it will move here. Okay, so this is what it does lah. So basically it will call this method, try to move the vacuum. So what this method does is basically check, okay, can this vacuum move to the north? If it can be moved to the north, let's say here, if can move to north is true, we move that vacuum to the north lah. Basically set the new collocation of the vacuum to the north. All right. Okay. So that process will happen until all of this square that we have here is converted to clean. Okay, so this vacuum here will randomly check their neighbors and then check their condition of the square and then convert the square into clean, and then again we repeat that process. Let's say it randomly move next to here, and then change that that the condition of the square to clean until all of this square here, all of the square that we have within this floor is all become clean. Okay, and then by doing that, we also calculate the number of square that is dirty, and then calculate set that the vacuum has sucked that square. So we increment the total suck here, that the one that I just explained just now. Okay, and then we also calculate the movement of the square. Okay, let's say just now it moved from here to here, so that one we consider as one move, and then until all of the square is clean, we calculate how many times the vacuum has moved. Okay, right. So that is clean and move vacuum. Clean the floor. Okay, so basically that is the clean the floor action from this run method. So after we have cleaned all of the square that we have here, and then calculate the square that needs to be cleaned, and then how many times the vacuum need to move, we then need to display the result to the user lah, basically. So what we have to do next is call this method, display the final summary. Just now we call display initial floor. So basically we randomly set the floor by dirty and clean, and then right now after we have cleaned all of the floor here, we will have to display again the condition of the floor with the summary of the process that we just did just now. Okay, so this display the floor summary method, basically what it does is this one. Okay, so it will same thing, because just now we already changed the condition of this square that we have here. So what we do is basically just call back the display floor method, the same method that we call for the initial floor summary just now, to display the condition of the floor, just to make sure that all of this square here is clean. Okay, so this method, same thing that I just explained just now, it will look through all of the square that we have here by x coordinate and then y coordinate, and then display the condition that we just set for each of the square. Okay, and then that is so. Okay, display final summary, and then display floor, and then that is best. And then after we display, then the program basically will ends lah. Okay, all right. So that is what the environment class here do. Okay, so all of this is a codependent class. Okay, and then there are main method here. So the main method that the main class here is to execute the process lah. Okay, so what we have here, main method. Okay, what we have here is the first two method is basically to just show the example lah. So what this do is basically first we set the square. We set all of the square to be dirty. Here we have 4 square, and then we create an environment here, new environment with the square that we have here, the floor, and then with the vacuum that we just create here, vacuum equal to new vacuum here. Okay, and then we will perform the action of cleaning and then displaying the result just now. Okay, this one is also the same thing. This is for example, and then This one is where we actually take the input from user and then do the process that we just explained just now. So what it does is basically first take the input from user, enter the floor width, okay, as an X. So basically this value here, 4 for example, and then we ask again enter the floor height, which is this value here, which is 2, 6, 7, and then by using these two numbers here, we then perform the action that I just explained just now in here. Okay, so let's see the program in action. Okay, let me move number 5. Okay, see here, this one is the sample that we have. So basically we initialize random condition of the square here, and then in the background they perform the action of cleaning, and then what will happen is after that we display the final result of that, which is all of it become clean or either null here. Okay, this is for example. Okay, so what we have here, enter floor width. For example, we want to set a floor condition 4 by 4. Hello? Okay, for width to be 4, floor height to be 5. Okay, when I click enter here, it will perform the initialization of the square here, which is to create the floor of 4 by 5, and then randomly set the condition of each of the square, and then perform the action of cleaning all of this square, the dirty one, and then calculate the movement of the vacuum that we have, and then how many square that we have sucked the dirty parts. Okay, let's show. Okay, see here, the floor height. So initially we have set the condition of the floor that we just set here, 4 by 5, and then randomly we set the condition to be dirty, clean, dirty, clean. This one is done randomly, and then we perform the action of cleaning the square, and then after that we display the condition of this square after it has been cleaned, and then we also display the summary that the 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 vacuum has done. Okay, so for example here, in order to clean this condition, this square here, the vacuum has to move 58 times, and then it has to suck 10 times the dirty square. Okay, if we calculate here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there's another one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are 10 dirty square here. Okay, alright, so that is basically um, uh, what this program does lah. So in general, for the conclusion, the reflect agent that Abiota has just explained just now is to explain that the vacuum here is what vacuum does basically as an intelligent agent. So it will learn from the condition of each of the square that we have here, and then try to clean it. So we don't have to tell the vacuum, okay, this part is dirty, you have to go there. No, what we have here, vacuum as an intelligent agent, what it does is basically it will learn from the environment that we just set here, and then clean that environment by itself. Okay, so first of course the vacuum need to take the condition of the floor lah, the general basically 4 by 5, and then it will learn through the condition that we just set, and then clean. I mean, after it cleans the square, it will learn the condition of the next square, and then try to clean it, and then records that square, that movement, and then that I mean it counts that cleaning as one. So this one basically means that it learns from the environment that we have. Okay, the environment has 10 dirty square, and then in order to clean this square, we need to move 58 times. So that is what we meant by simple reflex agent. The the vacuum as an intelligent agent learn from the environment and then adapt. I mean detect the location, the neighbors of the square and then the condition of the square, and then store the memory of whether how many times is a move and then how many square is dirty, and then perform the action of clean. Okay. All right. So I think that's it from me. Any question? Any question from the attendees or presenters?
Okay, thank you, Fahmi. Thank you.
Okay.
I'm going to do a quick recap of what our dear tutors did. Okay, in a quick way, just give you guys an overall presentation of one sentence. So today we did programming for the simple reflex agent, more well known as the vacuum cleaner. So our program has four classes, and the square basically three, because the main one is just basically a tester. Okay, if you forget about the test examples, which are just as they are test examples, if you delete them, nothing would happen, nothing would affect the program. What matters is just this one, and so we basically have three main programs. Okay, three main classes. So firstly, we started with square, which was what created our grid in its collectiveness. So the grid and the square has two variables, two types of variables. It has a status boolean of dirty and the instances of north, south, east, and west, which since they are references and we don't have any square yet, we're going to set the initial value to null. Then we're going to create two constructors for our class. One of them has only the parameter of dirty on its side, so just dirty. And the other one has dirty plus the other four references, okay? The second constructor. So this one has 5, this one has 1. Next up, we have a simple getter. Remember setters and getters? So this is a getter for the dirty status. It basically returns whether something is dirty or not, okay? And this one is the change state. So what does one do? It will change the state of something if it's dirty to false and else to true. Okay, just it will change the state. So imagine that the vacuum wants to clean. If it arrives at a dirty tile, it will clean, right? So it will change the status, change the state to clean. So for dirty, it will be false. That's why if it's dirty, we're setting the value to false. So next up, we have the rest of the program is basically just setters and getters for the 4 directions. We have the getter for north, setter for north, getter for south, setter for south, and same for south, east and west. So this program, this class, our square, only had 2 types of variables, 2 constructors, and 1 and get dirty method and 1 change state method. The rest of them were just setters and getters for the for direction references. And lastly, at the end, we have a toString. So what does a toString do? It will check if a tile or a square is dirty. It will set it to string D, acronym for dirty, and else to clean. So this is our square, basically, the thing that we're going to use to create our grid. Next up, we have our vacuum, which is the bot that we have. In here, we're going to have 3 types of variables. We have the square, basically an instance of this class. We call it location. We have the number of moves and number of socks, because in the end, we want to have a report of what went on. So we're going to set the initial values them to 0 because nothing has happened yet. So in here, we're going to have three important methods, basically two, but a sub method of move is pretty much what makes the move something that's able to move. I'm not gonna make it complicated, and bear with me. So we have the move and we have the sub. So let's start with a move. We're going to say we have this Boolean value of has move, and we're going to say to false. Why? Because when we set the vacuum, the initial value of the vacuum to somewhere random, let's say the initial value is here. Sorry, here. Okay. So it hasn't moved yet, right? We just set the initial location for it, but it hasn't moved yet. It hasn't moved to anywhere. So that's why we're setting the initial value of has moved to false. But after when it has moved, we're going to say try to move. Why do we say try to move and then we pass this parameter of integer, which is based on selecting a random number between 0 to 3, between 0, 1, 2, and 3. So why do we mean by this method and why do we even need this? So basically what try to move vacuum does is that it's going to, as we said, this isn't an intelligent robot. It has a simple reflex programming, simple coding, simple algorithm, okay? So it's going to try to generate a random number between 0, 1, 2, and 3. So if it's 0, it's going to try to move to north. If it's 1, it's going to try to move to south. If it's 2, it's going to try to move to east. And if it's 3, it's going to try to move to west. So you see here, again, we're going to have another sub method, which is can move north, can move south, can move east, and can move west. So basically, by intuition, you're going to understand, okay, so basically it's going to say, I'm going to generate the random number, true. I'm going to check if I can move there, correct, right on, bingo. But how do I implement it? So I get the concept of it, but how do I implement the permission to be able to move somewhere, to then be able to, satisfy the condition and move inside here? So we're going to go into two other methods. First one is the set location, which uses the parameter of square location that we talked about in the beginning of this class here. Okay. So what this one does is going to set the location inside here, so we can have a reference for the square that we're on right now, basically current location. And then we're going to have the can moves. So what are the can moves? They're going to use, and the references that we said, remember the getters, the get north, get south, get east, and get west. So we're going to say, okay, I'm at current location. Can I go to north? Does my get north have a value other than null? If yes, then can move north is true because we're returning a Boolean value. If it's false, then we're not going able to move. So what does this mean? Imagine that our vacuum has moved like this, 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 like this. Now it wants to go to east again. But the east of it is null. So it's going to say get in location, which is here, location dot get east. Okay, is it null? Yes, it is. So return false. It's not going to be able to go to east. So it's going to generate and try another one, either north, west, or south. Okay. So let's get back to it. So basically, that's what it does. It's going to try to move, and the checker for whether it can move to a place is based on the current location and whether it has a reference for the other 4 direction that it has. Okay. So to implement that, we can use getters. That's the good thing about getters and setters. Basically, you can use references in other classes. So the 4 are exactly the same. So let's get back to the try to move. So as you understood, if it's able to move, it's going to set the current location, set the new location to the current location. So what do I mean by that? So I'm going to say, yes, I can move to north. Okay. Then I'm going to say, can move to north, set this new location to my current location. Now my current location is here. So that's what each of these one lines are doing. They're basically setting the new location to the current one. So that's what try to move vacuum does. And after it's moved, basically after it has moved, it's going to increment the number of moves once because we want to get the total of number of moves as well. So that's the big part. The suck method is pretty simple. It's going to say, okay, is the current location I'm on dirty? If yes, if it's dirty, change the state because I'm a vacuum cleaner. If I'm a dirty floor, I'm gonna clean it. You know I will. So it's going to increment the number of sucks as well. And then we have the two just getters for number of moves and then number of sucks. So that's it for the vacuum class. So you may ask, okay, so we have the square and we have the vacuum. So how do we bring the functionality to this program? We're going to use environment. Environment is our big boy class, okay? It's going to have three types of variables, one object from class square. It's a 2D array, two-dimensioned array. So we can create this grid, a two-dimensioned grid, okay? Two dimension. So we have that, and we're going to represent it through a 2D array called floor of type square. And then we're going to create an instance of class object and class object of vacuum. And then we're going to create two integers for the dimension, x and y, and we're going to set them to 0 for them. Then we're going to have two constructors. One has a parameter of vacuum, then the two directions, and the other one has the vacuum and then the 2D array. So you see here, unlike the other constructors you've seen here before, that this one has methods in it as well. See, this one has create floor and randomly set state plus run, and this one has run. Never before, here, like here and here, you've always just been used to having your constructors being having the this keyboard, and that's it. Just that, nothing more. But you see that you can actually and call methods as well inside the constructors when you're creating an object. So what does this do? What does create floor and random set state do? Before I go inside the line by line code explanation, basically it's going to create your floor. It's going to create this floor that you have, okay? And then set some random tiles to some random squares to their thing. So here, 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 okay? So that's what it's gonna do. It's going to create a floor and then randomly set those random squares to 30, okay? And then it's going to run. You're going to see what run does. Basically, run keeps the robot moving and cleaning until the floor is clean. So in this one, we just have the run because we just want the vacuum. See, the parameter that it has is just a vacuum in the floor. But this one is the one that has the parameters for the dimensions. So that's why we have the create floor in this one and not in this one as well. So next up, we have two big methods. One of them is run, and the other one is the create floor and randomly set state. Okay. To understand these two, you need their sub methods. For now, I'm going to give you the intuition. So as intuitive as the name of the method sounds, it's going to generate the initial value of the location. Okay, this is for run. So I'm going to generate the initial value location for vacuum. So let's say it's here. So that's that line of code executed. Display the initial floor. This is for your log, the thing that you see when we run the program. You see the display initial floor. Okay. Then we have the clean floor, which will keep the vacuum moving around and moving and sucking until the floor is all clean. Okay. And next up, after everything is done, after this one finishes, because when it says floor is clean, it's going to go execute this one, which is give you the final summary of what went on inside the execution of the program in the random environment. Next up, you have the create floor and randomly set state. You saw this in the constructor in a moment before. So what does it do actually? Because we need to break it down, right? To have short methods, concise methods, both for spacing, for space complexity and time complexity. So this example that we did today, the vacuum cleaner, the simple reflex, is actually something that I would consider one of the best ways you can do programming. Why? Because it has short codes, so it doesn't take the compiler too long to basically compile one method, and it's using segmentation as its approach to represent instead of just creating these huge masses of codes that are just one method for the entire Java program. So I would suggest that you guys once in a while try this sort of sweet and concise way of coding as well. So back to it, we have the create floor and random set state. So first we're going to create the floor. Then we're going to generate the score. I'm going to explain to you guys why this part is separate from this part, okay? Why we need these two together, so we to get the this grid of squares. Again, emphasis on grid of squares. Environment created by linked squares. Okay, the emphasis I'm putting is that each of these are square object of square themselves as okay, each of them, not just the entirety of it. So after these two are done, we're going to have our environment created. So next up, we're going to link the squares that we just generated, okay, based on the dimensions. We're going to link them, basically stick them together so they can have their references like north, south, east, and west. And then we're going to randomly select some of them to be dirty. So that's what create one random set state does. So let's get to the small and sub method ones. So first up, we have the initialize floor. So what it does that it's going to say, remember the reference that I made, the 2D array of type square, we call it floor. So this is a new object of square. We're just creating an object, right? And we're setting the value of the dimensions to x and y. So that's the initialized floor, that's it. But right now, it doesn't mean that each of the coordination of here are squares themselves. So you need to generate to set each of them to be a square themselves as well. Basically setting that, okay, coordinate 0, 0 is a square. Coordinate 0, 1 is a square. Coordinate 0, 2 is a square, and so on until you. So for that, you're going to have to generate square class, okay? So what you see here that for the first time, that you have two for loops. Why? Because you have two dimensions, right? One for x, one for y. So you have an embedded for loop. So you can basically just iterate for both x and y at the same time. You know, useful. After that, we're going to use ing for coordination and setting that each of these coordinations are an object of type square themselves. And as our tutors explained, we're setting the initial value of their dirtiness to false, basically all clean for now. Then we have the link, okay? Link squares and random set and dirty. So again, because we're working on 2 dimensions, we're going to have 2 for loops, embedded loop. You're going to see this a lot in this class, okay? So link the east and west references based on the coordination. Link north and south based references based on coordination, and then randomly change states. You're going to see that each of these are method themselves. So first, I'm going to go inside the linkers. So how do we link the squares? So we understood that, yes, we need the squares to be linked so we can have the references. So you may have seen this during the presentation our tutors did. And you may wonder, why is this one I minus 1, or you may not. This is because imagine that the current location that we're on, let's say, I'm going to show it in a different color because I'm just showing it. And let's say 2 and 3. Okay, so what's east of 2 and 3? It's 2 and 2. Okay, so in here, it's just, you know, for east of it, we're decreasing 1 from the I. Okay, decreasing 1, so it's on the left side or the right side. Okay, based on how you interpret your dimensions. So that's why you have 1 minus 1. So it's setting, okay, the next one on me on this dimension, the next one to me on this dimension is this. And the next one on me on this dimension is this. And you can implement these using this way for ease. And you see, instead of here, instead of saying I plus 1 dot set west here, you have I minus 1. No difference. It's just, you know, to keep it concise, keep it the same flow. So by using the use of coordination, you're setting the east and west and references for your floor as well, for each of the squares. Same for north and south, and this time we're just working on dimension of j, which was y, remember? So this one worked on x, this one worked on y. That's why this is north and south, this is east and west. So next, we have the randomly changed state. So you're going to say, okay, so we understood that how you create them, how you link them, and how you basically create the environment. Now, how do we set the random squares to be dirty? So again, you're going to use 2 sub-methods. If randomly changed state is finished, then set the coordinations based on this method to be dirty. So change the state. Why by using change state they turn dirty? Because we set the initial status of it, state of it to clean. So by using change state on the certain ones that you randomly select, You set them to 30. So now you want to say, okay, so how do we randomly select them? Simple, just by randomly selecting them. You use the method random instead of creating the randomizer that we did for in the earlier sessions of part one. This is just a simple but very useful command inside the Java. Basically, it's a command from one of its math libraries. And we're saying just choose by a ratio of a little bit better than 0.2. So that's why you have bigger, not equal. Okay, a little bit better than 0.2. So next up, you have to generate the initial location of vacuum. So you have the random, we said that's random, right? So we're going to have the dimensions as random X and random Y. Then we're going to have our new syntax of the session. So the new syntax of the day is do while. So what does do while loops do? Basically, is as it sounds. Do something while a condition is satisfied. Okay, so it's going to say, okay, do this and randomizer randomly select two dimensions while these two are null. So when you finally found your randoms, okay, set them to be these coordinations inside your floor. Okay, set location based on this coordination. So that's how you generate your initial vacuum location. Next up, we have the printers, but I'm going to stay away from them because they're just, the cherry on top, the finalizer. So I'm going to move to the cleaners. So we have the clean floor. So now we're going to the sub methods of run method. Remember the clean floor, the clean and move. So what does this one do? This one will say until the floor is dirty, until the floor is not clean. You see the symbol here. So it's going to say until the floor is not clean, keep cleaning and moving. So how to implement cleaning and moving? Simple. Vacuum.suck, vacuum.move. So suck and move until this condition is satisfied. And then this program is going to cease function and stop. So next up, we're going to have how to check whether a floor is clean or not. Okay. So for now, I'm going to stay away from these two because these are just very simple printers and not hard. I'm going to just go inside the functions first. So again, because we're checking for the floor, checking inside the environment, we're going to use the embedded for loops again. So we have the first for loop for dimension X, second for loop for dimension Y. We're saying if it's not clean, if this is not clean, set it to false and return true. Okay. So this one will just check whether your floor is clean or not. But you see here that again we're using another sub method, right? Instead of creating these inside of this, we're creating these separate and then just making a reference of it. It's more understandable for you, for someone else who's reading your code, and for you when you want to review it or explain it. I would have had a much harder time if the name of this were, complicated or different. So it's good. It's a good practice, guys. If your method names and your class names are intuitive, understandable, clear. Even if they are long like this one, it's better to have it like this. So finally, we have to check if the floor piece, if each square is clean. So this one checked if each square is clean and then return false. Now we're going to say how to check for each square. Basically, try to see if this coordination, this exact coordination is dirty or not, and then return a value. And also to make sure that you don't get any exceptions, cache exception E, then close up and return true. So in this one just checks for one square. This one keeps iterating through your environment. It checks each square by checking each and every one of them. So it's going to go this, so on and so on. Okay. So now let's get to the final part, the printers. So you have the display initial floor, which is just, which will print your initial floor. But you say, how do I print a floor? We're going to go into that. So to print your floor, you're going to have, again, because it's two-dimensional, you're going to have two for loops, and you're going to say, print the square of this coordination. Again, we're going to have another method for printing one square. We're going to say, if it's null, set it to null. Okay, if your ing is not clean, has no value, set it to null. And then if it's not null, then print the coordination. And then we're going to use this one, when we're printing the entirety of the floor. You see it in the main method in just one moment. Based on that, just print the entirety of the floor based on each piece. That's what it does. And then you have the print final summary, which just, says this is the final floor, and then shows you the number of successes. So I hope you guys understood the functionality, how we implemented the algorithms. So now let's get to the tester. So inside here, inside this environment, we're going to just, see how our program is doing. To make it simple, I'm going to delete the pre-made set examples, so you guys see they're not important at all. Okay, just good old one main method. Okay, and guys, if you're wondering why we have this, again, this is a practice that we did. Okay, it's easier to do. I could just delete random and copy its code inside of main and run it like that instead of just calling this. It's better if you do this. But if you want to not do a method and just copy and paste this inside of here and not have a separate method for it, it's also okay. So let's run it. So first it's going to ask me for the width. Let's say, because I'm doing like this, let's say 7 and 5. Okay, 7 and 5. So he created these environments. Remember the print floor? So it's moving row to row based on the coordination and giving me these print value. Then the final, of course, when the program is done, is going to always be green. Why? Because the program has been finished. When will it finish? When it's all cool. So because of the large environment and because it's not very efficient, this is a simple reflex agent, it made 200 moves 200 times, and it sucked 20 times because they have 20 dirty states. So I hope you guys understood. And just because I don't want to make this incomplete, I'm going to paste the examples again. These are for you to, instead of having a random environment, you can basically create this environment that you're sure of, and then just using that as a example of it, as you see, static for the example, because you guys have created, it's not dynamic anymore. So I hope that's clear. So I'm going to ask you guys one question. How do you think we could have made the algorithm for our robot to be more efficient, make less moves? How could have we done that? Can you guys tell me? Can one of you tell me how we could have made it move less, make less moves and yet reach the same goal much sooner? Anyone? It's okay, guys. Give a guess. It's all right. Just give one guess that you might have. Any guesses? How could have we made the robot to be more efficient? Don't worry about the coding of it. Just give me, concept. How could have we made the robot to not make the repetitive move? Come back to the same tile over and over. It checked for each of them, because every time it comes, it checks for it. So how could have we made it, more efficient? Any guesses? Don't be shy. Come on, give me a guess. No one? It's okay. So basically, if you want to make this more efficient, you can have a method that checks for repetitive moves. So if your robot has already visited this tile, you don't check for it to be dirty again anymore. So you're going to skip right past that and go to the next one. So this way, it's going to change your agent because now it has some sense of the environment around it, but now it's more efficient. So that now you understand that different agents are literally different agents. They're just overlays on the simple reflex agent to make it more efficient. I hope that was clear for you guys. Any questions? Anything you'd like to ask about the program? Anything, guys? Any question, guys, about the program? Was it clear for you? Give me a yes if you understood the program. Give me a no if it wasn't clear for you, if you didn't understand. Yes, Carson, open your mic if you can, or put it in the chat box if you have any question.
Can you hear me?
Yes, yes,
I
yes.
have a request instead of question.
Sorry.
I have a request instead of question.
Okay, okay. What is it?
Can you send all the codes inside the project material?
Of course, of course, of course. Sure.
Because because I seem like there's just the PowerPoint presentation instead of code.
Understood. Sure. We'll send the code right
Okay.
away. Sure.
Thank you.
Did you understand the code? Did you understand the presentation?
Pretty much, but not all.
Which part did you have difficulty with? Which part do you think you need more explanation of?
It's about when from squares to element, the connection is a bit not that clear.
Basically, Carson, the connection I'm going to give the flow for you is that this square just sets, sets the attributes for each of these other squares, okay? The vacuum is just going to, create the vacuum attributes, not its functionality, okay? Just its attributes. So that's why we have one class for vacuum, one class for square. Now we want to create a functionality of the program, basically give it the sense of what to do inside the when we run the method. So we have the environment. So in general goes on inside the environment is that it's going to create this two-dimensional array of square objects. Okay, it's going to create them. It first going to initialize the floor, then it's going to segment it, set each of these segments to be an object of square themselves. Then it's going to link them. And after they're all linked, all of them connected, basically it will look something like this. Then it's going to randomly set some of the states to be dirty, okay? So that's what goes on inside there. So now we want the program to be able to implement the functionality of the vacuum. So now we're going to randomly select an initial location for the vacuum, let's say here, okay? And the vacuum is going to keep moving, it's going to call the method from its own class, from the vacuum class. It's going to keep moving until the floor is clean, okay? Or while the floor is not clean yet. So it's going to keep going on, keep sucking, keep checking for each of the floors. So imagine that this is a floor. I'm going to just show you. Here, 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 here. Okay, here, 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 clean. And sometimes it may, go, repetitive parts and then check the other parts. So this is what's basically going on inside the environment, okay? So it's going to, the vacuum object is going to keep iterating over and over until the floor is finally clean. The floor has no dirty parts in it. So that's what it does. Then at the end, after everything is done, everything is finished, it's going to give you a summary of what went on. So the summary is what you see inside your execution. So you saw that first you have an initial floor, so which is this one, and then you have a final floor, which is this one. Then you have the number of times the vacuum moved, and the number of times it sucked. So that's what basically is going on inside the environment. To give you more connection, the environment is using the square in a two-dimension grid. Okay, even if you don't want to even use the term array, it's creating this two-dimension environment for it. It's going to create it using connected squares, so they can have references. They would know what's to their south, what's to their east, what's to their west, what's to their north. Okay, so that's why we link them. And basically after that, after the environment is done, which will look something like this, we're going to release the vacuum and keep it going until the floor is all clean. How do we know if the floor is all clean? We're going to keep checking over and over through each of the squares to make sure that it's all done. So did I answer your question about the connectivity of the classes? Min Kang, are you clear now? Is it clear for you now? Or is still 50%?
Yes, I think, yeah, I understand the question already.
Mhm.
Thank you.
Thank you so much for listening. Great students we have. Any question, guys? Anything you want me to explain again? My time is for yours right now. Don't worry about the clock. If you guys are all clear, if you have no further questions, if you're all clear, not that you're unclear and have no question. If you're clear, if you understood what went on inside the program and you have no questions, thank you for joining us. Thank you for being here and have a nice day. Thank you for joining us. The rest of you who want to ask questions, feel free to open your mic or put it in the chat box, and we'll make sure that we answer each of your questions to give you guys a little bit more for Q&A time. Any question, guys? I'm going to give till 9:40 for you guys to ask any questions you want. So some of you may take a bit of time to type it out. So I'm going to give you till 9:40. If no question until then I'm going to dismiss the session and thank you for joining us. Those of you who have stayed, I would appreciate if you guys give us, as always, give us a short review of how you feel about the course, how you felt about the session, and we would appreciate it. It means a lot to us. Thank you so much.